Okay, so in this video, we are going to look at how we can use the Euclid's division algorithm to compute the highest common factor of two given integers. The highest common factor of two numbers a and b is the largest positive integer d that divides both a and b. Okay, so that is what an HCF is. Now, before we jump into the formal statement of the Euclid's division algorithm, let's try to understand how it really works. Let's take two numbers. The numbers that we are going to take are 455 and 42. And what we need to find is the highest common factor, HCF, of 455 and 42. Now, the way you would have done before is you would have found out all the factors of 455, 42, and then you would have looked at it and figured out which one is the highest common factor. Here, we are going to take a slightly different approach. We use the Euclid's division lemma, right? So let me just call Euclid's division lemma, or EDL for short. It says that any two numbers, let's say A and B, they could be represented in the form very uniquely as A equals B times Q plus R, where the number R is greater than or equal to 0 and it is less than the number B. Okay, so what we are going to do is we are going to use this statement of the Euclid's division lemma, or this, to see if we can come up with the HCF of these two numbers. So let's start. So now we start with the bigger number. So in this case, the bigger number is 455. So we have 455 and we need, so this is the number A. The number B is 42. So this becomes our B, and we need to find Q and we need to find R, B times Q plus R. So if I do 42 times 10, we'll get 420, and then we do a plus 35, that will give us 455, right? So this is the first step. Now we need to check the remainder. What is the R? Now in this case, the remainder R equals 35. Okay, so what we need to do is we need to apply the Euclid's division lemma again to the number B and the number R. So basically we will take a new pair of numbers, that is 42 and 35, and apply Euclid's division lemma to it. So if I were to write 42 is the larger number, the other number is 35. Okay, so this is our number A, this is number B, then you need to find Q and we need to find R. The number that we could just multiply it by 1 plus 7. Okay, so the new number that we now have is, the new pair of numbers that we have is 35 and 7. And in this case, the remainder, as you can see, is 7. Okay, now the remainder is still not equal to 0. So we need to apply the Euclid's division lemma to this pair of numbers. So we got 35 is the bigger number, and the remainder is what becomes your B. So we can say that this is A, this is B, we need to find Q and R. So 7 times 5 gives us 35, and then the remainder will be 0. Right? So here the remainder is equal to 0. And the number that we get are 7 and 0. So what we can say over here, that we cannot really proceed any forward in applying the Euclid's division lemma. So we can say that HCF of 455 and 42 equals 7. Now you can actually try to verify this for yourself by finding HCF with another method that you are aware of, and you will see that you will find the HCF will be the same as what we obtained through this method. Now let's kind of make a formal statement of the Euclid's division lemma and the Euclid's division algorithm, and how does it work. So the way to summarize this is, Euclid's division algorithm, EDA, Euclid's division algorithm, this is just my short form. It says that to obtain the HCF of two positive integers, let us say C and D, such that one of the numbers is greater than the other. So C is greater than D. Okay, follow the steps below. Okay, so step number 1, apply Euclid's division lemma. Apply Euclid's division lemma, EDL, to C and D. So what we need to really do is we find the numbers Q and R such that C equals DQ plus R, where R is less than the number D, but it is greater than or equal to 0. You do that. Now, once you have applied Euclid's division lemma to C and D, the next step you have to check is the value of R. If the remainder equals 0, then the answer is straightforward, right? Then the HCF of C and D is the number D. Okay, now if the remainder is not equal to 0, that means you still have a remainder, after applying the Euclid's division lemma earlier. What you do is you continue this process by applying the division lemma to D and R, right? So you apply Euclid's division lemma to the numbers D and R, and you carry on this till you continue this process until the remainder comes out to be 0. Okay, and the divisor at this stage will be the required HCF. Okay, when R equals 0, then the divisor that you get is the HCF. Now, why does this work? Well, this really works because the highest common factor of the numbers C and D is the same as the highest common factor of the divisor and the remainder. So that is it in summary, the example of Euclid's division algorithm, and at a high level the method to follow to apply that. In the next video we will solve another example using Euclid's division algorithm.